I want you to imagine something for a moment. Not a star, not a galaxy, not even darkness. Imagine a state where there is no space to stretch across, no time ticking forward, no direction, no before, no after. This is where our story truly begins. And no, this is not the Big Bang. Because the Big Bang, despite what you may have been told, did not begin the universe. It only describes a moment when the universe was already on its way. For decades, people believed the Big Bang was the ultimate starting point, the first tick of the cosmic clock. But science does not move forward by repeating comfortable ideas. It moves forward by asking uncomfortable questions. And the most uncomfortable question of all is this: if the Big Bang was the beginning of everything, then what caused it? And if something caused it, then the Big Bang cannot be the true beginning. When I studied the equations of general relativity, I noticed something strange. As we move backward in time toward the Big Bang, our equations break down. Density becomes infinite. Temperature becomes infinite. Space and time collapse into what we call a singularity. But in physics, infinity is not an answer. Infinity is a sign that our understanding has failed. It tells us that the theory is incomplete. So I asked a different question. What if the universe did not begin in the way we imagine beginnings at all? We humans are prisoners of time. Everything in our lives has a start, a middle, and an end. A birth, a journey, a death. So naturally, we project this idea onto the universe itself. But the universe does not owe us familiarity. The laws of nature do not care how comfortable an idea feels. When we look deeper, we discover something astonishing. Time itself may not have existed before the Big Bang, and if time did not exist, then the idea of before loses its meaning entirely. Asking what came before the Big Bang may be like asking what is north of the North Pole. The question assumes a direction that simply does not exist. This led me to propose a radical idea known as the no-boundary proposal. According to this idea, the universe has no sharp beginning. Instead of starting from a single explosive moment, the universe may have emerged smoothly from a timeless state, a state where space and time were blended together in a way our minds struggle to visualize. In this picture, the universe is finite but has no edge. Just as the surface of the earth has no boundary, you can travel forever without falling off. The universe may have no beginning point where the laws of physics break down. The Big Bang, then, is not the birth of everything, but a transition, a phase change. A moment when the universe shifted from a timeless quantum state into the expanding cosmos we observe today. But let us go even deeper. At the smallest scales, the universe is governed not by classical physics, but by quantum mechanics. In the quantum world, strange things happen. Particles appear and disappear. Energy fluctuates. Reality itself becomes uncertain. And in this realm, something extraordinary becomes possible. The universe may have arisen spontaneously from the laws of physics themselves. This does not mean the universe came from nothing, in the way we usually understand nothing. It means it came from a state governed by physical laws, even when space and time were not yet fully formed. Gravity, in particular, plays a crucial role, because gravity allows energy to be balanced. Positive energy from matter can be exactly canceled by negative energy from gravity. This balance means the universe can exist without violating any fundamental rule. No cosmic trigger is required, no external push. The universe is capable of creating itself. This idea unsettles many people. They feel it removes meaning or purpose. But I would argue the opposite. A universe capable of understanding itself is far more profound than one that requires an external explanation. We are not spectators in a meaningless accident. We are participants in a universe that follows deep, elegant laws, laws that allowed stars to form, planets to assemble, and life to awaken. Now consider this. If the Big Bang was not unique, then our universe may not be alone. Modern physics allows for the possibility that many universes exist, each with its own properties, its own laws, its own histories. In such a multiverse, the Big Bang is not a singular event, but a recurring process. Universes may be born the way bubbles form in boiling water, each expanding into its own reality. Our universe may simply be one of these bubbles, a region where conditions happen to allow complexity, structure, and eventually observers like us. This does not make our existence insignificant. It makes it rare, and rarity gives value. But let me be clear, these ideas are not fantasies. They emerge from mathematics, tested again and again by observation. The cosmic microwave background, the large-scale structure of galaxies, the behavior of black holes, all of these whisper clues about a deeper reality beneath the Big Bang. Black holes, in particular, teach us something profound. Inside them, time and space reverse roles. The future becomes unavoidable. The past becomes inaccessible. If such strange behavior is possible inside black holes, then it is not unreasonable to believe the early universe behaved in ways far stranger than we can easily imagine. In fact, the birth of our universe may resemble the interior of a black hole turned inside out, a transformation rather than an explosion. The Big Bang may be less like a firework and more like a doorway. So what did begin the universe? The honest answer is this. The universe may not have begun at all, at least not in the way we understand beginnings. It may have always existed in some form, not eternally expanding, but eternally governed by timeless laws that allow existence to emerge naturally. This does not diminish wonder. It deepens it, because when we ask why the universe exists, we are really asking why the laws of physics are what they are, and that question pushes us to the edge of knowledge, where science and philosophy meet. Someday we may discover a single simple theory that explains everything, a theory so elegant that it fits on a page and reveals why the universe must exist exactly as it does. When we find it, it will not feel like the end of mystery, but the beginning of understanding. Until then, we should remember this. The greatest enemy of knowledge is not ignorance. It is the illusion of certainty. The Big Bang was never the final answer. It was the opening sentence of a much longer story, a story still being written, and we, astonishingly, are part of it. If the universe did not begin with the Big Bang, then our role as observers becomes far more important than we once believed. Because the universe is not just something that exists independently of us. In subtle and surprising ways, it is shaped by the fact that we are here to observe it. In quantum physics, observation is not passive. At the deepest level of reality, outcomes are not fixed until they are measured. This means the universe is not a finished story waiting to be read. It is a story that becomes real as it unfolds. And this has profound consequences for how we understand cosmic origins. The early universe was not a solid object or a single path through time. It was a cloud of possibilities. Many different histories were possible. Many different versions of reality could have emerged. What we call the history of the universe is simply the path that became consistent with our existence. This is not mysticism. It is mathematics. When we apply quantum mechanics to the universe as a whole, we find that the past is not uniquely determined. Instead, multiple pasts can exist simultaneously, interfering with one another like waves on the surface of the sea. The universe does not have one single origin story. It has many possible ones, and the one we experience is the one that allows observers like us to exist. This idea is known as the top-down approach to cosmology. Instead of starting with a fixed beginning and predicting the present, we start with the present and ask which histories of the universe are compatible with it. In this view, the universe we see today selects its own past. This changes everything. It means the universe is not a machine wound up at the beginning of time and left to run. It is a dynamic system where laws, structure, and history are deeply connected. The question is no longer what happened at the beginning, but why does the universe allow us to be here at all? When we look at the constants of nature, the strength of gravity, the charge of the electron, the rate of cosmic expansion, we find something extraordinary. If these values were slightly different, stars would not form. chemistry would not exist. Life would never arise. The universe appears finely balanced, almost as if it were tuned for complexity. But this does not require intention or design. In a vast multiverse, many universes may exist with different properties. Most would be empty, short-lived, or chaotic. Only a few would be stable enough to allow observers. We find ours, elves, in such a universe simply because we could not exist anywhere else. This is not a statement of arrogance. It is a statement of humility. We are not special because the universe was made for us. We are special because we are rare, and rarity is powerful. As our understanding deepens, we also discover that time itself may not be fundamental. It may emerge from deeper, timeless laws. In some approaches to quantum gravity, time dissolves entirely at the most basic level. The universe does not evolve in time. Time emerges as a byproduct of change. This suggests that the universe is not marching forward from a beginning to an end. Instead, it exists as a complete structure where past, present, and future are woven together. Our experience of time flowing is a feature of consciousness, not a property of the universe itself. This idea is difficult to accept because it challenges our intuition. But intuition evolved to help us survive on a small planet, not to understand the origin of everything. When intuition fails, mathematics becomes our guide. Black holes once again provide crucial clues. At their boundaries, information behaves in unexpected ways. Nothing is truly lost, even when matter disappears. Beyond the horizon, its information is preserved. This tells us that the universe is far more orderly than it appears. If information is never destroyed, then the universe is not fragile. It is resilient. Its structure is protected by deep principles that operate beyond space and time. The same laws that govern black holes may govern the birth of universes. In this sense, our universe may be the result of a natural transition, not an explosion, not a creation from nothing, but a reorganization of reality itself. A shift from one phase to another, guided by laws that do not require a beginning. So when we ask, what started the universe? The most honest answer may be, nothing needed to start it. The universe exists because the laws of physics allow existence, and those laws may be inevitable. This does not strip the universe of meaning. It gives us responsibility, because if the universe can exist without a beginning, then its future is open. And our actions, small as they may seem, matter. We are a way for the universe to know itself, to question itself, to reflect on its own origins. That is not a small role. Science does not replace wonder. It expands it. Every equation we write, every observation we make, pulls back a curtain and reveals something deeper. The universe is not silent. It is speaking, through light, through structure, through laws written into the fabric of reality. Our task is to listen. The Big Bang did not start the universe. It was a chapter, not the first line, and the story is far from over. The most exciting discoveries still lie ahead.